Welcome back to Spencer Kelly's AI Masterclass Part 2. The Masterclass was so busy that we just couldn't fit in all of the questions that we were getting from the audience. So my excellent guest has agreed to come back and answer some more. Dr. Michael Pound, welcome back. Thanks for doing this.
No problem at all. I always enjoy answering questions, and there were a few that we didn't get to, so it's good to go back.
As a reminder, Mike is star of the Computerphile YouTube channel, which features some really, really good deep dives into computer science. So you're also an associate professor of computer science at Nottingham University, which basically means you deserve to be a professor, but you have to wait until someone
That's what I'm telling them. Yes, it's a waiting game. I'm working as hard as I can.
Okay. How long has Computerphile been going now, by the way?
At least 10 years now. Right. I mean, I've been on it for since 2015, something like this.
And this is a spin-off of Brady Haran's Numberphile channel, isn't it?
Yeah, so Numberphile is really, really successful. There are other channels like 60 Symbols and periodic videos as well for different subjects, and Computerphile span off of this. So it's kind of like a sister channel, and it's become sort of successful in its own right.
I do wonder, actually, whether all universities are full of such excellent communicators, or whether Brady has just hit on Nottingham University and every single professor and lecturer there is brilliant, because you all really are great.
I'm not sure really how Nottingham and Brady got linked together originally, but of course, Martin Poliakoff, Professor Sir Martin Poliakoff,
with the hair,
for chemistry, led the way with periodic videos. But Numberphile is mostly not Nottingham, right? So you get loads of great people from other areas. I think we are very lucky. I think there are lots of good lecturers across the UK, right? And I wouldn't claim to say that we have a monopoly on it. But on the other hand, I'm very proud of the videos I've done, and I think they've gone well.
All right, let's crack on with these questions then. I've got a list of them here.
Yeah.
And they are coming at you in no particular order, right?
Okay.
Be warned. Stephen Durrant says, and this is a good general one to start actually, what is the biggest mistake most people are making right now in how they're adopting AI at work?
Okay, well, yeah, I mean, there's so many potential answers I could give, right? I think what I would say, at the moment, a lot of organisations are working under this kind of general rule of we need to be using AI for something, but we don't know what it is or what that thing is, right? So they're going in blind and they're just plugging things together and hoping it works. I think a better way to frame it is, what is one thing that you just wish you could solve, right? So maybe you're fed up of some specific thing that you're doing, and then see if you can solve that problem with AI, right? Come up with concrete examples of small things that you can have a go at. And in doing so, you'll also learn about how the AI works and what it does and doesn't do. So for example, in Nottingham, we run limited trials on, let's say, using it for Excel productivity or for using it for emails. And then the results of those will get fed back to the wider, staff, depending on how they go, right? And I think that's probably a better way to do it. Almost all companies I see are just kind of throwing things into and just seeing if it works, right? And sometimes yes, sometimes no, but you can waste a lot of time that way.
Do you think there are a lot of cowboys out there, a lot of AI cowboys saying, come and use our LLM products, and companies, like you say, are feeling like they need to do it?
There's a difficult balance between paying someone to do something that you sort of can't be bothered to do, right? Or you maybe are unable to do, and kind of being fleeced for something you could have easily done yourself, So there are loads and loads of companies out there that are, what we might call the AI startups, right? And a lot of them are doing, good stuff. And some of them are just putting a fancy front end on someone else's model, right? Which you could have done yourself. So I think it's a judgment call as to which you do. My suggestion, I guess, is start off with the free stuff, and then if it works, then consider maybe upgrading it, right? Rather than, jump in with some expensive product. It turns out that actually there were free alternatives, which there often are.
It kind of feels though like you have to do some sort of time and motion study. If you're going to try and identify a part of your business that you would want to make easier and is possible to make easier with AI, you kind of have to get someone in to properly analyze that. I mean, what scale of tasks do you think people should be
Yeah,
thinking.
I think definitely start small for that reason, right? It's easier to work out what's happened and whether it's actually been a benefit, right? So a limited number of staff members. Let's say you want to use an AI to help drafting emails for some particular system where you have these very repetitive emails that you're writing all the time, right? And what you do is you have a limited number of staff, you have a limited period of a study, and you essentially try and work out qualitatively, at the very least, whether they feel like they've been empowered by this particular product, right? And whether they feel like they've saved time. I mean, if you wanted to be more scientific about it, you could actually time how long these things take. But of course, then you're spending so long timing the timing that you end up spending more time actually with the test than you could have done just trying the thing out. A lot of it is intuitive, but you also don't want to fall into the trap of assuming something's better just because it kind of exists and is AI. So, there are studies that show that some people are getting faster with AI coding assistance, and there are studies that show they are not getting faster, but they think they are, right? And it's very, and disentangling that is very, very difficult. So the smaller and easier the task, it's more likely to be successful, and you're more likely to know, whether it's been successful, I think.
On the subject of coding, we talked about the fact that LLMs can generate code for small tasks quite easily. I've seen it mentioned now that there's a new job out there, which is the job of correcting the errors that LLM introduces into code. And I wonder what the real benefits of letting LLM code are, whether it's quicker to generate the code, but then you take just as much time or longer actually fixing it afterwards.
Certainly, I think the net gain is minimal. It's not the instant code that you assume it is, right? If you've got a very simple problem and you just ask an AI to write it for you, it will probably write it. It will probably be correct, right? And if you decide then not to check the code because maybe no harm done, it's not very important, you can kind of say, well, that will be quite quick to do that. If you run in what we would call production, right, in software development, where everything you do is going to end up in front of some customer, and the ramifications of getting it wrong are so serious. So that, you work for a credit card company and you're going to be denying or giving people credit cards or sending them bills incorrectly or what have you. So you need your code to be correct. And we are not at a point where we know that the output of a large language model is correct, right? Often it's quite good. And so what you do is you essentially kind of shepherd the model while you code. So you sort of say, can you write me a function to do this? And you look at it and you audit it and you test it and you're pretty happy with it. And so you put that in the code base. And then you say, now, okay, can you write me a second function? And the better you are at programming, the faster this will be, because you can read through its code much more quickly. You know how big a task to give it. You don't just say, can you do all of this work and I'll come back in 2 hours? Yeah. And you find it's just wasted 2 hours of absolute nonsense, right? Or you have to spend 10 hours fixing it. So I think we're at the point now where there are incredibly useful tools, but you want to think of them as like someone who's just learned to code and is pretty good, but you can't rely on them and treat them with that kind of, just that care, right? But don't just pick up what they've done and throw it out to the customer, right? Give it some thought and testing first.
So it'd be like taking on an intern or maybe a work experience people from a computer science course, and they're top of their class, but they are not schooled in the corporate stuff and the security stuff and the good work processes and stuff.
Yeah, and libraries that these AIs are relying on change a lot as well. So often for those people who don't code, they may not know what a library is, but a library is essentially an already developed piece of software or software package that you can make use of within your own code to speed.
So it'd be like I'll make this up. See where the mouse pointer is and do something, or put a keyboard on the screen. Yeah. I think of them as the kind of, let's call them low-level tasks that have already been solved, and there's no point everyone writing their own bit of code to sort a list of numbers. Someone's done it. It's there. It's as good as it's going to get.
Yeah, if you're in Python and you want to shuffle a list, you just call the random.shuffle function, right? You don't write your own. It's a complete waste of your time, and it won't be as fast as theirs, right? Yeah. So, there's no point. And AI is particularly good at writing this kind of code. So if you say to an AI, how do I shuffle a list in Python? It will just say random.shuffle and it will be completely correct, and that will be great, right? The question became, what happens if Python changes, right? And it isn't random.shuffle anymore. It's random unsought or something like this, right? I'm making up words. Now, that doesn't happen for major languages, but it does happen for other libraries quite often. And you'll end up with 2 pages of written code from this AI, but it's kind of last year's version. It doesn't work, right? And you can't work out why it doesn't work. And it takes you ages to debug. And 1 minute in the documentation would have told you, okay, that's actually what I should have been doing. And so you can kind of go down these rabbit holes where the code that's produced looks very, very good, doesn't actually run, right? And you've got to try and work out why. So you're definitely going to come a bit like when you're using it to write narrative, like write text. It's going to look okay, right? But when you sort of dig into it, you think, actually, I could change that bit and I could delete that. And that's a bit repetitive. And you might work with it to produce that long document. But just this idea that you can just go home and let it write all the documents itself, we're not quite there, I don't think.
My experience with vibe coding, and I did some videos on this last year, where I made it a little fun game, which it did very well. But I also wrote a little utility. I've got loads of high quality audio files in WAV format that I wanted to turn into MP3 files. And so I just got it to write something that took all of the WAV files and made copies that were MP3. Then I realized that I hadn't specified it correctly. So I wanted it to also move the metadata over and create names based on the metadata. And it worked fine. And like you say, it was a utility I used just once. And I didn't need to check it. I checked it on a test folder. So I didn't let it loose on my entire music collection until I tested it and was happy that it genuinely worked. But after that, I've never used it again. So that's fine. But also I tried to, just on the subject of libraries, I wanted to turn some of my audio interviews into video files where images would be pulled in that are relevant to what's being spoken about. And I just couldn't get it to work. And it was because it was using a library that was out of date. And so this library was kicking out errors, and I was feeding those errors back into the large language model, and it was saying, oh, well, let's try this and let's try that. And I believe it just didn't know about the new libraries that it had to use, exactly like you say.
And even when it learns about the new libraries, it's still going to have a load of training data based on the old libraries, right? Because a lot of this code is trained off websites like GitHub, and GitHub has loads of open source software on it, some of which is out of date, some of which is wrong, some of which is correct and up to date, right? And it's a bit of a mix. And so, again, it always comes down to the more you know how to code, the more you can kind of identify this as soon as possible and correct where the large language model is going. Because it may have been, but if you'd have been able to ask it and use this version of the function, because that's the new one, that might have been sufficient to get it in the right place. Yeah. But until you see it, you don't know, right? Yeah. And you could waste a huge amount of time. I think vibe coding is a really interesting concept because in a way, vibe coding is coding if you don't know what you're doing, right? In some sense, whereas kind of AI-assisted coding, you could be a senior developer or you could be a junior developer. And I think that this idea that you could produce like a banking system with vibe coding is not realistic, right? You're gonna get the initial website looking like a bank, and then everything else is going to break, and you're going to
vibe code a banking system.
Right?
I love that. That's a sitcom right there. That is.
Yeah, but the kind of the hype around AI is that actually within a few years this is what we'll be doing, right? They're genuinely saying we're not going to need programmers. Which by implication is saying we don't need coding of the banks, we don't need coding of cryptography, we don't need, when you buy a train ticket, none of that needs to be coded by a person. That can be done by an AI. And you just think when you've had problems just on a simple game and simple, file conversion, is that realistic at this time? So maybe we learn to live with AI as a helper rather than as a replacement.
So a kind of runner rather than a systems developer. Do you think that when you're talking about a banking system or a ticket booking system, it's orders of magnitude more complex? Do you think that will, for a good amount of time, be out of reach of these large language models? Because, when you increase the complexity, you're kind of squaring or cubing the number of iterations that this thing has to go through.
There are tools like Cursor, which now will look over all of your files and try to make more substantive changes to code based on, so you might say, I want to add this feature, and it knows it has to go into these files to do this. Now, I think the results will be similar, right? Which is that it will sort of work, and then it will not work, and then you have to fix it, and so on. And I think you have to also consider the massive cost of running these models. The more time it has to think, the more time it has to try and fail and try again and fail and try again, you're running large language models and incurring actual money cost every time you do this. Yeah. And often the way that these models will work is you will be basically paying by the minute that they're in use. And so
it's just like dial-up.
So you could, or the number of tokens they produce, right? Which of course is dependent on the complexity of the problem and how often they work. So you might say, add this feature, I'm going for a coffee. You come back and you've accrued £1,000 worth of debt, right? And so, as long as there are limitations involved and you know what you're getting into, and sometimes they are very efficient and they within $30 have done 2 weeks work, right? And that's fantastic. But at the moment, you don't know until it's happened which of those two it's going to be. And so I think you have to just go in knowing what could happen, right, and be a bit careful.
So when I hear reports that companies are no longer hiring junior coders, it sounds plausible because they're just getting LLMs to do it. But then after listening to you, it doesn't sound like that's happening at all.
Yeah, I mean, bearing in mind that I work at a university where all of our undergraduates apply for a lot of jobs every summer, right? And the vast majority of them are getting software development jobs. So they are hiring. It's just that there's kind of this slight downturn across quite a lot of sectors, not just software development, just with the general economy. I think there will be some companies who are naively trying to replace bits of their workforce with AI, and they're going to have a bad day when they realise it doesn't work. Right now, and you also have to think like, well, suppose you've got a senior developer who's working with a tool like Cursor, right? And suppose they're incredibly good at working with it. They know what to ask it. They know how to get the best out of it. You could maybe squint and think they might double their productivity. Right now, I think that's massive overestimate. But let's pretend for a minute that they do. You've just replaced like one job. You still got to have that expensive senior developer who probably now commands quite a large salary because of how experienced they have to be in this. Have you saved any money? Right. I mean, it's a good question. We don't know the economics of it. I think as we were talking about, one of our other questions was talking about how could companies best make the use of this, right? And I think it is about testing and seeing before you jump in. Right. So test how well the coding works before you fire 500 junior developers and then realize you can't get anything done. And the other thing is, I think there's an argument that says, suppose every one of your developers gets 20% more efficient, is the argument that we then let 20% of them go, or is it that we become 20% more productive as a company and make more profit?
Yeah.
Right.
Yeah.
So actually, I don't know about you, but every time I get better at doing a job, I get asked to do more work. Right. And
yeah, story of our life. We just prove that we're fast.
Yeah. So that may be what happens instead. We may if AI has this incredible uptick in efficiency, it may be just we get more done.
Yeah. On a similar question, you might have answered it, but because it's written here, Richard Smith. Why do you think so many organizations are saying that AI hasn't delivered the benefits they were expecting?
I think that there are a few reasons. One is the AI definitely doesn't match the level of hype that's been produced by the tech companies, right? Sometimes this whole argument seems very black and white, right? You've got people who are saying AI is either going to destroy us all or be absolutely useless. And then you've got people saying we've got AGI and, we don't need to ever work again, right? And of course it's somewhere in the middle, right? Which is that it's an incredible thing, but also that it doesn't completely replace you. And I think that maybe companies are not doing that smart, careful rollout of some of these tools. They're just throwing things at problems under the assumption that it must make it better if it's AI. And it doesn't really. If you think about an email drafting system that we were talking about. So let's say I have a specific role answering a lot of student queries. Let's say I try and replace myself with an AI to save money. I think in reality what will happen is you might be able to get an AI to draft some of the emails for me, which I then edit and send out, and that saves me a bit of time. I think it's unlikely it's going to be able to correctly answer all the emails. And so we should have never bothered to ask it to do that, right? That's, I think, what a lot of companies are doing. They're saying, let's just automate this problem because no one wants to do it. Actually, just make everyone that's doing it a bit more efficient, right? And it's a more grounded problem. It's easier to solve. You've got a human in the loop, so you don't find yourself on the news when you've sent out a load of really rude emails by mistake. There's lots of pros for doing that.
Just on the subject of hype, I mean, I hear it and see it reported a lot that, AGI is just 2 or 3 years away. And also, you hear about books being published about how AI might be going rogue and might release itself onto the internet and protect itself. And I just wonder, if I was one of these big AI companies that just needed continual investments, would I just let those news stories happen and not come and counter them? Because it's all kind of reinforcing the idea that we really are getting somewhere with AI. So I do wonder whether they're just letting this happen.
That's absolutely the case, right? If you're a company, you and I start an AI company tomorrow, right? And we want everyone to buy into our company. It's much better for us if everyone thinks we're on the cusp of a change the world has never seen before, right? This idea that it's bigger than the Industrial Revolution. I mean, people are underestimating how big the Industrial Revolution was, right? In terms of its transformative change on the.
I was there. It was very smoky.
I might look very young, but anyway, but it's way too early to say, right? I mean, I think that most of the researchers that I follow or I read about, like Jan LeCun of formerly of Meta and now of his own company, right? He developed one of the first convolutional neural networks. He's been at the forefront of AI for many years, and he says LLMs they're about as good as they're going to get. We're not going anywhere with them. We need to start looking at other things, right? Geoffrey Hinton, who famously won the Nobel Prize for his work on AI, says that they're about to become sentient and destroy us, right? Now, one of them is wrong, by definition. I'm on the Jan LeCun side, right? And I don't.
So am I, and I struggle to understand why people who are that renowned would say something that even to me feels obviously wrong. I mean, we'll both be eating our hats next year when Geoffrey.
Yeah, that's exactly right. We can caveat this.
Yeah, but
I find it interesting as well. I think the people who work for the companies maybe have a slight vested interest, right? And they're also caught up in this almost zealous kind of excitement about something that's new and incredible, right? It's a cool thing to think you're at the absolute cutting edge of something that might be the biggest thing we've ever seen, right? And I can imagine that's quite addictive. As someone like me, who is a kind of normal researcher who doesn't win Nobel Prizes, right? And there's time. But I've come to terms with it. It's fine. But the point is, I'm a bit more grounded. I'm a bit more willing to look at it and go, well, that doesn't seem like what I've actually seen when I talk to this thing, right? And also, these are just mathematical models. We talked about this in our previous session, right? They just do matrix multiplication, right? Lots of mathematicians do matrix multiplication. It doesn't mean their piece of paper's coming alive, right? And so I think, I don't know how good an argument that is, but
at a Click Live show that we did at the Hay Festival a few years ago, we demonstrated how matchboxes could beat you at noughts and crosses in a machine learning kind of way. So there's a pile of matchboxes that gradually accrued a different number of red and white beads, and that represents the weight of the neural network, if you like. And then you play against this set of matchboxes, and I would class that as a kind of intelligence. This system was learning by playing against all these other people how to play better noughts and crosses. And it's not sentient as far as I know.
If you do machine learning, the first thing you learn is something called linear regression, right? Which is fitting a straight line through something. So you have some data that's going up like this. You just draw a line through it. That's machine learning, right? As long as the machine is the one that calculated the line, you've learned that function.
So it's fitting from training points. It's fitting the best curve to it and hoping that. If it's not
even linear, it's not even a curve, it's a straight line. You could fit a curve, but you could fit a line. But actually, every piece of machine learning up to and including large language models are essentially the same, right? There's just more numbers they're fitting. And so the difference between me and the Geoffrey Hintons who have this idea that this could become, much bigger, basically boils down to this idea that you get this emergent intelligence coming out of these numbers, right? So you add enough of these numbers and you suddenly have a human brain, right? Whereas I'm yet to be convinced that either that is true or that we are at all close to that kind of scale, right? You know, it could be that if your large language models becomes trillions of parameters, it becomes more aware than it is now. I cannot say for sure, but it won't. I doubt it. But we haven't got enough parameters, and we're already using most of our electricity to power these things. Is that practical? And so I think that over the last couple of years, the trend has been towards everyone sort of accepting, okay, we don't think it's going up like this, right? Partly because ChatGPT 5 was not so much better than 4, and so that kind of plateau is showing up in these models. And a lot of the models now, but let's say are getting much better at coding, it's more about what training data they're giving it and are they asking it better problems. So, you know, you might say, well, why is ChatGPT 5 much better at coding than 3? Well, probably because there's a separate model specific for coding buried in ChatGPT 5, whereas 3 was a smaller model which didn't have separate parts, you know, and things like this. So that isn't necessarily an argument towards AGI. It's just that they're using these things in a smarter way.
I do wonder, or I'm fairly certain that large language models are never going to become artificial general intelligence because they are just predictive text and will always be predictive text. There is no amount of expansion that you can do to them which will let them do all the things that an AGI system.
It's a really interesting argument to have because I don't know the answer. Right? I agree with you in the sense that that's my feeling as well. I wonder also if it's the fact that we're limiting it to text, right? Vision language models are technically not text, but they're close enough to text in the way that they're trained that I think we can just put them aside.
I think, yeah, am I right in thinking that they've been trained on an image and its metadata and the descriptions of those pictures? And when we've met before to film for Click and stuff, we've talked about the fact that, first of all, it seems to turn an image into text if it's analyzing an image, or the reverse if you're trying to create an image. It works from the text description.
What it basically does in practice is it turns the image into a numerical set of numbers which are representative of the text of that sentence, right?
Yeah.
And so, you know, if we just put that aside, there is a lot more to being a person, I would argue, than the text that I read. I'm not reading most of the time, right? Babies don't read until they're 5, 6 years old, and yet they seem to have learned some stuff before they get to that point.
Yeah.
And we do it on massively reduced amounts of data. We do it on, if you show someone a horse, right, who's never seen a horse, and then you say, could you imagine a small version of this that looks a bit stumpy, and it's called a pony, and they've never seen one, they go, yeah, I could imagine that. Can you draw it? And they could draw a pretty good pony just from your description of it, right? That kind of, for what we would call it zero-shot learning, this idea of just being able to do something by extrapolation, is something that machine learning really struggles to do. And I think we have not worked out how to do that well, which is why we need all of the internet to train these models, because we're just trying to shove something that doesn't want to be shoved, you know, into a place.
Just to ram home, unless I'm wrong, the understanding of why large language models might not get better if you put more training data in. That's basically what we're saying. That is
the trend that's been seen in a lot of research as well.
Yeah, it's unlikely just by doubling the amount of training data that you're going to get double the performance. It's because of all the maths that goes on, and as you say, matrix multiplication. So if you, and I'm going to get nerdy and geeky here, but if you imagine a matrix of 10 by 10 numbers, that's 100 numbers, and it's multiplying those together several times. If you were to, let's say, double the size of, let's call it double the size of the dimensions of that matrix, suddenly you've got a matrix of 20 by 20 numbers. You've actually increased the size of the matrix by 4, not 2. If you try and increase the training data by a factor of 10, you could be increasing the amount of time the LLM takes to work through all the processes by a factor of 100, 1,000, 10,000, a million, and it becomes impractical.
If you think about the size of a current model, so the first ChatGPT was in the order of 100 billion parameters, right? The Llama 3 model that Meta open source, that's 175 billion parameters. So these are the numbers in the matrices. DeepSeek, which famously went viral because it was really good and it seemed to be trained on more modest hardware, 670 billion parameters. To give you an idea of what kind of computer you need to run that, you need 8 graphics cards and 0.5 terabyte of RAM. So I don't know if you've got any machines with you now that can try it, but Yeah,
That'd be a bit
I tried
short.
running it on mine, did not work. So it's now conservatively estimated that the new Gemini is a multi-part model, but is some trillion parameters, 1.5 trillion. So we've gone up by a factor of 10, right? Is the new Gemini 10 times better than the thing we saw a couple of years ago?
It's difficult to quantify, but yeah, you can see why the answer could be no.
It's probably better than it was before,
Yeah.
right? So let's say by in the order of some number of percent, but probably not 1,000%. Do we want to multiply it by 10 again with the tenfold increase in electricity costs for training? And OpenAI makes a loss of some number of billions, right?
Standard in technology terms, isn't it? You make losses for the first 10 years till you've disrupted the industry, and then you can charge whatever you want once you've killed off the...
Is the argument going to be that we need more funding because we're going to make our model 10 times bigger and it's going to get 10 times better, right? And if that's the argument being made, I don't know if that's borne out by the evidence, right?
Yeah.
We shall see. And again, they're running this idea that once you hit some threshold of size, that's the AGI, right? And I remain to be convinced that's the direction it goes.
Why are they giving us these models for free? They're so expensive. I can't help wondering whether every time we use them, we are also training them. And that's why we're doing these companies training for them.
That's one part of it. At least I think at the beginning that was one part of it, right? They're collecting a lot of training data. They probably have enough training data now, in the sense that I think most of the changes you see in ChatGPT are to do with specialized training examples like puzzles and coding that they can put in on purpose to try and get the best out of it. I don't think it needs to read any more Wikipedia pages, right, or any more nonsense chats I have. I think the main thing, and I'm sure that someone who's watching this who knows all about, an analyst for a company who knows all about how these venture capital funds work, how they work, might have a better idea. But I get the impression that their goal is to become ubiquitous, and then that's when the money starts rolling in, right? So suppose you're ChatGPT or your Llama or your someone's model, Azure, it doesn't matter. You develop this model that's so good that everyone goes, all right, well, that's the one we have to use, and we're all going to use it for free, so why not, right? And then you get all the world using it, a bit like Facebook. Lots of people are on Facebook, and at that point, it's very difficult for a competitor to turn up. It's very difficult for everyone to change ecosystem, and so on.
Yeah.
And so, at some point, the promise to the funders is we're grabbing all the customers, and then the money comes in, right? And I think the question is, will the customers pay when they get asked to? Or once ChatGPT starts putting adverts in amongst all your stuff, are you going to go, I can't be bothered with this, right? Or are you going to still press on? I don't know.
I mean, history does not make me hopeful, because that is how technology VC has worked. And I interviewed Daniel Ek, the boss of Spotify, when he was just launching his service. And I told him, because I used to work in commercial music radio, that his model is not going to work, because he'll need 9 minutes of adverts every hour to pay for his service if he's giving this music away free. And of course, what I didn't realize is he could afford to go hundreds of millions of dollars in the red over the course of a few years until he'd killed the old way of buying music, at which point then they can turn it up. I've noticed my Amazon Prime, which I pay for to watch movies, is putting adverts in there, even though I'm paying. I've noticed on Spotify, even though I'm paying, there are adverts creeping in on top of the podcasts. And so, once they disrupt the old world and kill the old competition, if you can afford to do it for that long and make hundreds of millions of dollars worth of losses, I think the roadmap is that, as you say, then they can start charging.
The main issue for AI companies, I think, is what some might call the moat that they've got, right? The competitive advantage. So for a long time, OpenAI had a huge competitive advantage because they seem to have the best model, they seem to have all the users, they seem to have the best, Gemini has just ramped up in performance massively because Google's got a lot of, and then you've got people like DeepSeek coming out of absolutely nowhere with a model that's pretty good, right? So the question, I guess, is suppose that ChatGPT has a new model where there's advertising, or we will pay a premium subscription, right? And we're all happy to do so because it's ubiquitous. What if someone comes up with a free model that is as good? We all just immediately bail, right? And so I guess the question for them will be, how do you keep customers when other people can also train models? Right? And I think they haven't answered that yet. It's difficult. There's companies like Apple and Google with Android. They get people sort of in the ecosystem a bit, right? And that stops people moving. But if Android started giving away their phones for free, you're not going to see a lot of iPhone purchases, right? So I think I think with AI, the gap between the kind of pretenders to the throne and the people at the top is not so big. It may be.
Really
that's the thing you have to worry about.
Yeah. Let's go for another question. I've got 3 questions here that are all kind of grouped together. So I'm going to give them all to you, and then you can answer whichever bits you like. Nigel Smith, how do you stop employees taking incorrect information and churning it out in quotes or projects, and then it becomes company output, which is incorrect? My concern, he says, is how this false info is going to be separated from real academic research, say, in the next 100 years. Are any companies creating large language models with closed academic sources? So this is eliminated, or is humankind destined to lose its history and culture to a false mess of slop? How can academic centers around the world prevent this, which seems to me rather serious? How are academics dealing with this? Now, there's a second question from Randy Schofield. Randy Scoville, what is a cost-effective way to check generated work? And there's a third question. Michelle McDermott, as a genealogist, I'm skeptical about information found on the internet. AI is only as good as the information uploaded to the internet. Will it be possible, probably in the future, for AI to verify or cross-reference the facts it uses to generate the written text? So loads of questions there, basically around whether we or AI itself will be able to fact check itself.
Yeah. I mean, they're fantastic questions, right? So in terms of people working in your company, the only policy is to have a rigorous policy that you enforce. That's the only way to do it, right? You cannot stop someone who's determined to not do anything and use AI from doing that, apart from they want to keep their job. So you need to, as quickly as possible, come up with a set of rules about how people, use AI for work. Because the other thing is that their colleagues don't want huge swathes of text written by something that isn't a person, right? Because it's just wasting everyone's time reading it. So, they want to know that their colleagues are putting in the same effort everyone else is. And so I think it's about people being proud of their work and wanting to do the best job that they can, right? Hopefully. So I think a clear set of guidance and rules, right, and some ideas on how you would use these things. So again, it would be unwise to say, please write me a 2-page essay on X, right? It would be better to say, I've been writing a 2-page essay on X, and I'm stuck on this bit. Could you kind of come up with a couple of bullet points that summarize this argument for me, and then use that to write that bit of text, right? And go back and forth, and that way the whole thing is written by you.
You're jamming. You're kind of vibing. You're jamming.
Yeah. And that's no different from popping onto Wikipedia to look up something.
Or talking to a colleague that probably has an encyclopedic knowledge.
Yeah. I think that's the way to do it. And educating your staff is the way to do that. I'm sorry, I've forgotten the second question.
Well, it's about fact checking. So there's a question about whether actually, because AI is training itself on things it finds online, if that includes lots of AI generated stuff that's not guaranteed to be accurate, how do we stop that? And then more generally, how do we check AI generated work is true anyway?
The programmer in me wants to say you fall back on deterministic code, right? So what I mean by that is, if you do aside from the AI summaries on Google, if you, suppose you're doing referencing for an academic article and you want to find papers in a certain area, right? Now AI might be able to help you with that. So you say, I want to find a paper where they use large language models to test the efficacy on programmers, right? And it will spit out some references for you and say, this paper did it, this paper did it, this paper did it. And they probably exist, but they might not, right? And it might misrepresent exactly what the claims of the paper were or mis-summarize them. So then you go on to what we call Google Scholar, which is Google's engine for papers, the search engine for papers, and you find those papers and you read those papers, right? And that's just part of being a good researcher. You know, it's the same conversation I have with my PhD students, right? Yes, you can produce a text description of a bunch of tools that exist in the literature by using AI. But if you haven't read those papers, you haven't learned how to be a PhD researcher, and it's probably wrong.
Is there not a problem as well, though, that there's more and more AI-generated papers being published?
It is. The peer review process isn't perfect, but it will help. So if you're looking at papers from reputable journals, it's likely that at least some senior academics have read those, right? And, you know, I review dozens of papers a year, right, for various journals. And although I am not immune to sort of not noticing that it's AI, you know, you can tell sometimes a paragraph might have been helped with AI, but you just sort of let that go because it's not such a big deal. But, you know, you're looking for the results. You're looking for evidence that they've done the experiments they said they've done, you know, and you cannot rule out that it's complete fabrication, but it's quite unlikely, right? Because those researchers are not going to be doing themselves any favors. If that ever got found out, their research career is over. So it's not worth the risk for most researchers. Yeah. We've never done it, for the record, right? So, you know, I would expect a researcher to be typing in all the numbers of their results by hand. You know, it's one thing to use AI to help write your introduction, but why would you help it write your results table, right? So, you know, that's very, very important, and you have to have some faith, I think, in the other researchers in the community to do similar.
So, from what I'm hearing, how you check whether something is true is you go to a human and you ask them to follow the threads and the trails. At no point, I don't think, did I hear that you thought AI itself could check its outputs.
So that's the last question, right? And that's I think where we're going, and it's interesting. So sometimes when you talk to one of these chatbots, they will search the web, right? And the output of that process will be much more accurate than the output of one where they haven't searched the web, right? Almost by definition. Retrieval augmented generation, which we've talked about before, that by putting these documents in, the answers you get are much better on average. And so you could probably, if you said, here's a PDF of a paper I'm trying to understand, when in section 3.3, what do they mean? I would say with sort of 99% certainty, you'll get a pretty good answer back, right? But you put the PDF in, you know, and you did the legwork to say, this is the specific question I have about this text. You didn't just say, I want to know about this topic and hope that text finds its way into the AI's context. So I think you have to do a bit of legwork yourself. You know, the people that, you know, you see in the news with lawyers getting in trouble for making up precedents and things, right? That was when they gave too much over to the AI. They assumed it couldn't write something that was completely fabricated because I guess maybe they're applying their own sense of moral duty to something that doesn't have any sense of anything. Right?
Yeah, it's just maths, people. It doesn't have a brain.
The sentence might be true or it might be false. It doesn't care either way, right? And so, I think, you know, due diligence, you know, really just assume it's not going to be correct and check it. But when you quickly find out that it is correct, that's great, and you've saved yourself some time.
Yeah, my worry is that AI will be right more often, to the point where we'll just assume, you know, it's too much work to check it because 1,000 times it's right and 1 time it's wrong.
We did a video about AI slop the other. So for those people not familiar with the term, AI slop is just this sort of generalized term for something of just AI generated content of no real value, right? You know, it rewrites something that already exists, or it makes something up. And I think the big issue with AI slop is it goes forward, because there's now research that suggests that AI content is out. There's more of it being output than human content. Yeah. And so it's going to become increasingly important to be able to find the human content if we're not sure about the quality of the AI text. And at the moment, there aren't systems to reliably produce that. If you search on Google for a topic, you may get real answers, you may get AI written answers. And it's up to you kind of to find out which of them it is. Yeah. And I don't think that's necessarily a good thing. So you might find the emergence of more curated data where you say, like, as you go on Wikipedia, and you could be pretty confident because of Wikipedia's pretty rigorous editorial rules that a human wrote most of this. And so why search on the internet when you can go directly to the article on Wikipedia and get something you know
Yeah.
is more accurate, right? Within reason, So I think maybe that's where people go, right? Maybe they start.
I do.
targeting
You
it.
know, obviously, connected with the BBC, and the BBC is trying to make sure people know that it is a trusted platform. And I wonder whether we are going to just go to those trusted platforms, Wikipedia, BBC, and others, because they are the only places where you know that some rigor has been put into the publication of the
If we
fact.
jump ahead 10 years and let's say video production and audio production is so good that you can now recreate the set of the BBC News verbatim, right? If that's the case, you've still got the issue of what is it saying? What is the news? And unless they're very careful, I would still watch the BBC, right? Even if I couldn't tell which was the BBC, because I know that at least my hope is that there's someone in there has done some fact checking, right? That's their job to do that, and I think that's going to become increasingly important. The less we are able to check the facts ourselves.
Ian Jackson asks, can we expect that AI delusions will decrease? And then has a specific example. It concerns me. We're looking at uses in medicine, especially around ambient voice transcribing. So actually, Ian's not talking about AI misdiagnosing you, but even something as, well, let's call it secondary, as voice transcribing a doctor's notes. So the main question then, can we expect that AI delusions will decrease?
I think for specific tasks like voice transcribing, I think we can expect them to decrease, because in some sense they're a very specific task, and actually the performance on those subtasks is pretty good, right? If you think about training some kind of big neural network, it's easier to train it to do something very specific like that than it is to train it to do everything. And so the specific jobs are working better than the general jobs.
Yeah.
And so maybe we end up with a bunch of systems built up out of all these specific parts. In terms of hallucinations, like, from large language models, the evidence is not good, right? They've reduced the percentage, but not really, right? And the other issue is that they've reduced the percentage not by changing the way that these large language models work. They've just increased the representation of those problems in the data set. So let's imagine that they find out that it's particularly bad for hallucinations when it talks about some war in history, right? They'll just get a couple of experts to write a few essays on it, put that in a training set, and now it's much better at answering this problem. They haven't solved the problem of hallucinations. They target. And I think it would be naive to think these companies aren't doing this exact thing. They're going on the internet, they're finding the things it doesn't do, and specifically targeting them for the next version to make themselves look even better, right? And because that's what I would be doing if I was there,
So it's fixing the symptoms, addressing the symptoms rather than the condition.
And they would push back on me and they would say, well, we'll just keep fixing your symptoms till there are no more symptoms, right?
Yeah.
I remain to be convinced that will work, right? Yeah. And there's always going to be a problem. And then we get the question of what if you actually want to ask it something new? There is no training example for this thing I'm asking it because it's genuinely new. What's it going to say? And the answer is we don't know. It'll probably have a good go, but it's going to be a bit weird.
Jamie Bartlett, best-selling author, friend, and also host of the Missing Crypto Queen podcast.
Awesome.
Which new episodes have just been released. Got in touch. He's writing a book actually called How to Talk to AI and How Not to. And he would like your thoughts on reasoning models. And I assume these are the chain of thought models.
Yeah.
Are they materially different to the more traditional large language models? It says here, people like Gary Marcus would say they're basically the same, but just take a little longer and have a slightly more sophisticated scripts.
I tell you what, why don't I give you two answers, the optimistic view and the cynical Gary Marcus view, right? And then you can choose which one you prefer, right? So the optimistic view is they are substantially different because it was very difficult to solve some of these problems without reasoning through them. We reason through problems, so why not try and train a model to be a bit more like that? So, we talked about box stacking. You've got a box stacking problem or a Towers of Hanoi problem you need to solve. Instead of just trying to solve it, why not go, well, I need to move this over here, and I need to move this over here, and I need to think about it in a bit more in a structural way. And given that all of it, this is just network context anyway, having that derivation in the context is going to help. Right? And this has proved particularly effective for things like mathematical equations. So if you need to say, can you prove this fundamental theorem for me, it's much more likely to do it if it's able to think its way through. And by think, I mean write down the steps.
And just to clarify, then, these reasoning models and chain of thoughts models, if you ask it a question that's even vaguely complicated, the first thing it will do is not give you the answer, but within its own notepad, write down what it understands the question to be and the steps that it might look at to solve them, and then it might even expand each of those steps in diary note form to itself, and this is what it is then reading as well as your question in order to work out the answer.
Yeah, and it did seem to have a pretty impressive performance boost on mathematical problems and complex physics equations and things like this, right? For just asking it why is the sky blue, it does the same as it ever did, and it probably doesn't even need to think about it, right? So let's turn to the other side of the coin, right? So the more cynical interpretation. What thinking actually is with respect to a chatbot is it writes the word think, then it writes some stuff, and then it says stop thinking, and then it writes the answer, right? So it's still just outputting the next word in the sentence. It's just that the first one is a token that says I'm about to do a thinking bit, then it does some stuff, and then it says I've stopped thinking now, I'm going to answer the question. And when the user interface says thinking, it's just waiting for the large language model to say I'm done thinking now, right? And again, it's not actually thinking like I would go silent and then come up with an answer and say it. It's writing. It's me. It's if I answered every question in your AI masterclass by first verbalizing my internal thought process.
Yeah,
right? That's what it's doing. And the actual LLM is exactly the same as it was before, right? And it's not any more parameters. The training set is only slightly different. You just include some of these thinking examples.
See, I'm in that camp because I've seen, you when you ask the question to something like Gemini, you can open up what it's thinking, and it is writing down this kind of diary to itself, and then it's working through those, and it might be writing down the results of the first step, and then so I'm absolutely of the thought that it's still a large language model. It's just creating its own inputs to go along with your question. It's working off the whole lot.
And perhaps the most interesting thing is, if you think about it from the point of view of a company, it was a natural, lovely extension when they were about to run out of steam, right? So they had this thing called the scaling law, right? And the scaling law was this idea that when you double the size of your network, you double the performance, right? Or you double the size of the training data, you double the performance. I can't remember which one it was. And they had this nice line going upwards, right? Now, that has not been the case. It's gone like this. It's plateaued out. But then someone went, oh, hang on, we can make them think for a while first. And so they had this new scaling law where if we double the size of the thinking, we can do this. So what you're doing is you're trading off training time for inference time. So inference is when you're running the model, when you're actually talking to it. And let's say the final answer is 200 tokens long. So it costs 200 passes through the network to produce this. But now you've added 500 of thinking, but your answer's better. So you've now spent 700 tokens answering a 200 token question, but the performance is better. And so what they're scaling there is the amount of computation you have to do when you produce the answer rather than at training time.
This reminds me of, you're familiar with Moore's law, obviously, the idea from the 60s that computer power will double, and that's power as in processing power, not power consumption, every 18 months or so. And it wasn't actually a law, it was just something that the computer industry aimed at. And they were able for a long time to double let's say the speed then of a computer every 18 months by shrinking the components. But then you got to the point where you couldn't shrink the components anymore. And so they changed the material that the chips were made of. Let's say they replaced silicon with, I don't know, gallium arsenide or something like that. And that gave them an improvement. But it wasn't, so they're still achieving the numbers, but they're trying to find new ways to do it. And then they could hyperthread and parallel process and that. So it still looked like the thing was getting twice as fast, but it wasn't in the spirit of the original.
And perhaps one crucial difference is that with a CPU, if you make it twice as fast, but it costs the same, you've doubled your value. With a large language model, if you use 700 tokens to produce 200 tokens of output, you've doubled the cost, right? Or 2.5 times the cost, or whatever it is. So there is a cost involved in scaling up inference as well as there is scaling up training. And we're starting to reach a plateau on that as well. I mean, you know, the other thing is no one wants to wait for 20 seconds for a thing to answer a question, right? You were there
That's
for the
the
answer.
problem. I'm so impatient these days.
Yeah. You can now select a thinking model or a not thinking model, right? And you can just say, I don't want you to think. I want you to give me whatever rubbish it is. I want it quick. It was an interesting natural extension, but it involves very carefully producing training data a lot of the time, or what DeepSeek did, which is really clever ways of training it, because these models don't naturally think or write down these thinkings. You have to train them with those examples. You have to have examples of mathematical problems and the thought process required to solve those mathematical problems. It doesn't just appear.
And so then there's anyone who thinks they're going to come up with novel solutions to physics or maths problems might be waiting a long time then, because they need to already have been shown the processes that get the answers.
You occasionally see on X, you see some grandiose claim that it's just produced a new mathematical proof that's never been produced before. It's possible that would happen, because you might have mathematical proofs that kind of, if you imagine they sit here and you can find a kind of proof that sits between them, and you can see how that might work. Most of the time that this has been claimed, it's turned out that those proofs were basically on the internet and it found them. Right? Or it took two halves of two other proofs and jammed them together. And it's a cool thing that it's done, but it's not quite the same as what they were claiming. Yeah. The hype with which they claim this, which is basically we've just created a new Einstein, is often not founded. And so a lot of fact checking is needed. Interesting side note, the thinking that you see when you read these models is not the real thinking they're doing. They hide that. They hide it from you. That is a company secret, you see. And so OpenAI famously, for example, they use another language model to summarize the thinking, and that's what you see, right? To get rid of their trade secrets. Yeah. So,
of course, it makes sense when you say it.
Well, because actually, it goes back to these other companies offering free versions of paid products, right? If you actually produced really good training data by just asking ChatGPT, what do you think other companies are going to do? They're going to just start buying licenses of ChatGPT and piping the output straight into their model.
Of course.
Yeah. Which they are doing, incidentally. They're all doing it.
Of course they are. Of course they are.
They don't like it when the other companies do it, only when they do it. Yeah.
Got a question from Craig Scott here. Pretty general. How is AI in education going to play out?
My hope for AI in education is that we can instill in everyone a kind of love of learning, such that we can use AI as an enabler of education, right? To ask questions that we don't understand, to talk through problems with us, to help us, but we don't use it as a short circuit to allow us to skip that learning process, right? So, for example, I've found that AI can be very, very helpful in learning to code well if you never allow it to give you the answer, and you allow it to give you hints, or you ask things you don't understand. You know, I saw this on the internet and I don't really understand this line of code. Can you explain that to me? That's fine, right? But once you cross that line into do that problem for me so I don't have to do it, it's a bit like trying to get muscly with someone else lifting the weights at the gym. It isn't going to work. And so I think at the moment we're in this kind of unknown where it's appeared very, very suddenly. We don't know how to best deal with it. And everyone's kind of panicking and going, well, we mustn't use AI for education because it's going to do this and that. Some of that is true, right? If everyone just uses AI, they won't learn anything. But I think it could be a huge tool for people to understand things they didn't quite understand. You know, you sit in a lecture for 50 minutes listening to me talk, right? Now, I would like to think that everything is very well explained. But let's suppose that if I go a bit fast on something, right, or I assume some prior knowledge that they didn't have, they can go and ask later. They can find out about that, and they can, under their own steam, they can catch themselves back up really well with tools like this, right? But if they didn't do that and they just ride it out to the end and then try and use VI to get past the assessment, they're going to massively undermine their learning. So I think I'm optimistic, right? I think we will work this out, but we're in that limbo at the moment where no one knows what the heck's going on, and we're all just sort of putting out fires over here and here, and it's going to take a little while.
Yeah, I mean, much as I'm not a fan of exams as being the best test of, you know, skills going forward, it does feel like coursework is very vulnerable to having AI help it, whereas controlled condition exams at the moment seems to be the thing you need to use to prove whether the students have learned it, even though, they're massively biased towards and against different types of pupils.
Something I think that's changed over the last 10 years, and it's a side effect of lots of different things, right? Like tuition fees going up and the way that A-levels are run and things like this in the UK particularly, for those people elsewhere. But I think it's true of most countries actually, is that university is now seen as you pay this money and you get this degree, right? And the assessments are the things that you have to do in between those two endpoints, right? So the only thing that matters is passing these assessments such that you get the degree at the end, you go and get a job, right? Whereas, of course, actually, it's completely reversed. What university should be about is you learn the stuff, and the assessments and doing well in the assessments is a side effect, an obvious side effect of knowing stuff, right? And then when you get to the end, you're really good at your job because you know the material. And so I think in some sense we've temporarily lost the argument of what you're there for. And that means AI makes a lot of sense, right? Because you're there to pass the assessments.
Yeah.
I think it shouldn't matter whether you have coursework or exams, because in an ideal world, all the students understand that if they use AI for the coursework, they're only hurting themselves. But we're not in that world yet. So as educators, we've got to put that message out, right? And I think a lot of students do get this, and a lot of students I know refuse to use AI because they know that they may have an issue with its sustainability, and there are other reasons not to use AI. But actually, a lot of them know very well that they're going to have to do a programming interview when they go to a job after 3 years.
Right. Yeah.
And how's that going to go if you didn't do any programming yet? Right?
Yeah. So that is the exam. Basically, even if it's coursework all the way through the degree, there will be an exam under controlled conditions to get that job, and it's something,
and you cannot skip it, right? Yeah. Because ultimately, if you want that job and the company's asking you to go in and do a couple of hours of coding, what choice do you have, right? And for those people who know how to code, it's never that hard, right? These are usually like past credit card numbers and stuff like this, right? Very, very simple stuff. So that isn't the issue. They're not doing it because they're hard. They're doing it because they want to do a quick check to make sure you actually know what you're doing, right?
That's brilliant, because I thought I could see that just going towards, exam courses are screwed, but no, the job interview, because I was thinking that, I maybe wouldn't care if I got the degree and then I got the job, then I could busk it for the first few months and actually learn them. But
for some jobs, that may be the case, right? Let's take another example where let's say you've done like a journalism degree, right? And a lot of I actually haven't done a journalism, so I couldn't tell you what's in it, right? But let's imagine it's writing essays on how certain journalistic things were done and learning about the way that these things are done. If you fobble that off to AI, and let's say hypothetically that you get away with it, you're still not going to be very good.
Yeah.
Right? Now, you might be able to blag, but you're not going to be able to do as well in an interview as someone who's absolutely attended to everything throughout their degree, or someone who's passionate about it, because it goes hand in hand with that passion as well, right? If you're phoning all the coding off to AI, maybe you don't like coding that much, and computer science isn't for you.
Yeah.
So when you get to an interview, you're not going to be able to convince someone who's a very senior developer or senior management that you have the passion, the working with people, the ability to code, all the things that you need to get that job. And we're in an ecosystem where sometimes the jobs are harder to get at the moment, right? For lots of different reasons. So I would encourage anyone watching this who is tempted to use AI to offload some of their work during their degree. They are exchanging that for making their lives more difficult later. Right. I don't want to be too much of a downer on it. You who's looking, right? If you already have a job,
Oh no! Shot down the argument at the last minute. No. Here comes Elliot. Elliot says, we seem to be at a stage where different large language models are good at different things. How do you see this situation evolving? Would there be one LLM to rule them all? Or will it move towards a suite of LLMs, depending on the job you need done, like an LLM version of Microsoft Office, for example?
Yeah, it's definitely the latter, right? So I think the ship has sailed on very big, what is single LLMs. They've started splitting them up even internally into these kind of mixture of experts where you have different branches of the LLM doing different things. But if you talk to ChatGPT 5, it's almost certainly not a single model you're talking to. It's almost certainly a router, which is an LLM, which goes, it's a coding question, off it goes to here, right? It's a physics question, it goes to here. And there are lots of benefits to doing that from the company's point of view as well. First of all, the individual performance on each task gets better. And also, your models are smaller, right? So running a router that is 10% of the normal size and a programming module that's 10% of the normal size is 20% total, right?
Yeah.
Compared to 100. So your inference is quicker, it's cheaper, and these companies, as we've mentioned, are giving this away a lot for free right now. It's a huge saving. If you can reduce the number of tokens required, let's say, to produce an output, or if you can reduce the amount of electricity required per token, that's massive savings at scale, right, of the number of queries that these companies are handling. So I think we're definitely going to the latter. Now, whether they will be part of a single tool, so maybe you will have your Azure router or your Copilot one that does all the work for you and everything is good and it all works, or maybe you know full well that the Gemini coder is much better than the one that's built into ChatGPT. That I think is undecided. I'd imagine it'll all get pretty good. But yeah, people like having one ecosystem as well, don't they?
Yeah, I do wonder when we talk about AGI, artificial general intelligence, whether instead of having one brain that's good at everything, we do have this kind of collection of AIs. One's good at physical things, and one's good at computational maths type things, and another one's good at language, and that whole collection of different AIs could be called an AGI if you could have specialists in all the things that we're at.
Yeah, in some way, it's kind of like how a room full of people is probably more intelligent as a whole than one person, right?
Yeah.
And actually, I think that's a logical. And we have parts of our brain as well, right? The bit of my brain that talks is not the same bit that moves me around.
Yeah.
As far as I know, I'm not an expert. Please don't email me about this. That's I think where we're going. And you could imagine a system that had so many parts that between them they were super intelligent in some sense. Now, whether they would be doing quite what a person is doing, I don't know. Probably not. There's probably still text-based, right? The thing that I think many researchers think is missing is some kind of model of the environment and the world, which is not in large language models, but is in other branches of AI. So
I
maybe
think
something
I've
like that.
seen DeepMind, which is the company that I put separate to everyone else, actually. I don't know whether you might agree or not, but DeepMind seem to be doing like what I would call proper AI rather than just the large language model, the natural language processing that then attaches to everything else. I think I've seen them start to very realistically simulate a physical environment. And that's the argument I've heard of why robots are slow to arrive, because you can't do the speed of learning with a robot in the real physical world that you can with an AI that's running a lot faster than the human brain.
And also,
a robot can't. You'd need 1 million robots running at 1 million times the speed of physics to learn how to get about a room.
And also, a robot's how you interface with a robot and how it interfaces with the world and interacts with the world is so fundamentally different to natural language.
Yes.
Right?
Yeah.
Are we actually suggesting that what we would do is write a description of the world and environment it's in, have it describe what it's going to do, and then that, it's not going to work.
Yeah.
It's completely stupid. And it's you have to have very bespoke and very specific ways of controlling robots, which requires a lot more development. It's very, very hard. I mean, to give you, some idea, yes, we see robots walking around from time to time, right? And the four-legged robot dogs are getting really good at running around. But they are still running, they're mostly hardware based, which is good. They're not running these kind of big networks. What they're doing is lots and lots of sensor input. And I'm tilting slightly to the left, move this gyro to move me back, right? Lots of feedback and control.
Well, that's machine learning, isn't it? That's a computer learning for itself what happened.
In a way, a lot of it will have been programmed by hand, but it will be adapting to the signals coming in, right? And using that. And what they can also do is they can use like visual algorithms. So they can use a LiDAR to put lasers out and work out where everything is and start building up as they see more of the environment, the shape of the environment, right? Which is what we do, right? We look, we see, okay, I know what shape that bit of the room is. Now I look over here and okay, now I know what shape that bit of the room is. And I can picture myself in this world. And that's what we're trying to do with robots. But, things like hand manipulation and running on 2 feet, they are tough. Right?
So I've seen both of those. What was interesting is in the last 2 or 3 or 4 years, I've seen things like hand manipulation simulated. So these robots are learning not by grabbing a ball in the real world millions of times, but they've managed to simulate the physics so well in a computer that it can run millions of simultaneous simulations and probably at a higher speed than physics, because they've physics can operate because they've got a good idea of how that ball will behave. And that's what you need for machine learning, isn't it? You need masses and masses of training data, unlike a toddler who could learn how to.
That's exactly the distinction, right? So at the moment, because the machine learning is how it is and it needs lots of data, we need to find ways of giving it that data. And it's not plausible to have 10,000 robot arms all holding 10,000 different kinds of ball, because we don't have enough balls, we don't have enough arms, right? And we don't have enough space. So we have a few arms doing real stuff, and we have a lot of simulated arms doing a lot of simulated things. And if we can get that simulated data to be close enough to the real data, it will work, right? Or we can transfer over. There are branches of machine learning called like zero shot and few shot learning, which is about trying to train instantly on one example. But the performance of that in things like robotics is not there. So, that's where we got to work towards. And it is intuitively what humans are best at. Right? We just look at, if you say you've never picked up my particular key fob of my car, you are not going to struggle with that process, right? Even though its shape is unlike anything your hand has ever held before, right? I could print you a really weird, I've got a little toy 3D printer. I could print you a really weird shape. You'll still be able to pick it up, right? And you'll still be able to interact with it and describe that shape to me. And you've seen no examples of that ever, right? And so we are not, machine learning is not doing that. And so that, I think, is the really interesting problem to solve, is how do we get it to do that?
Couple more, if you're okay to stay. I just want to ask something topical here, and it's about Grok and the bikinis.
Oh, yeah.
So Grok is X's AI that you can ask a question of just through the X stroke Twitter, I will always call it Twitter, interface. And what people have been doing recently is putting a photo, usually a lady, on there and saying, put me in a bikini, and then Grok will put them in a bikini. I've seen not quite counter arguments, but people defending Grok, saying all AI image models can do this. You can do this on Gemini and stuff. So why concentrate on Grok? And so I wonder what your thoughts were on, is there something different about Grok and the way that it was, maybe how easy it made it to do that and just put the images out for everyone to see? And is there a way that you can put guardrails on those kind of models, even to stop them doing things that you haven't thought of yet?
Very interesting. So everyone is right? Everyone but you've just quoted. The way that diffusion models work is they take some noise and they turn it into an image, right? And I'll tell you a quick story, because I think it will help explain. So originally there was a model called stable diffusion. It was one of the first ones, and it was basically an implementation of a variant of diffusion models that was particularly good. In a publication came out. They implemented it as a very big model, and it was unbelievably good. But there were concerns at that time that it was using loads of copyright data, it was copying a load of people's stuff, right? So what they did was they tried to train another model where they'd taken out loads of the artists and they filtered everything and they were much more careful. And the thing was rubbish. It didn't produce good anything, because it turns out all those artists were producing really good training data. So it is absolutely the case that every single diffusion model is capable of producing those kind of images, because they are trained on that data, because it's too difficult to sift all of that data out of a training set, is one reason. And the other is, the more training data you use, the better the model performs, even if you don't end up using it for that purpose, right? So the fact that the models can produce all this data is you could argue, a little bit troubling, right? But a natural side effect of the way they are produced and the way they are trained. A lot of them originally were trained on the Lion 5B data set, which is 5 billion images. That had really problematic material in it, and they had to take the website down and go at it again, because they just scraped 5 billion images off internet, and there isn't anyone that can look at 5 billion images. That's too many images. So they didn't know that the stuff was in there, apart from it was obvious, right? And so that was why these models acted so poorly. Now, why is Grok different? Because it is different. It's because you don't ever talk to the diffusion model. You talk to a chatbot that calls the diffusion model as a tool. So you might say, can you draw me a picture of this? That prompt doesn't go into the image generator. Grok says, I'd like to generate an image, and they ask for this, and here's a description, and it might add its own colourful bits to it and all that kind of stuff, right? And most AI companies will have coded some safeguards in, or they have an LLM that refuses to do it, or what have you, that stops that from happening. And Elon Musk and X's policy has been, we are not going to put those safeguards on Grok. We want it to be more powerful, or more free speech, or whatever it is they've argued. So they don't train it in. So the large language model happily passes your request onto the underlying image generator, and the image generator is absolutely trained to do that. Right? With Gemini, it just refuses to do it, and it never asks the image generator to generate an image at all.
I think I have seen people have sent me examples of where other large language models will generate similar images, but what you're saying is that there's generally guardrails on the other ones. They might be able to be circumvented, but
yeah. So to get something like DALL-E, which is the one that's used in ChatGPT, to produce problematic images, you would have to essentially coerce the ChatGPT model itself to ask for that image.
Right.
And I mean, there are prompts that will work, right? And you can go around, but in some sense, you're going against their user license agreement, right? Whereas with Grok, it's very much kind of what is suggesting you did in some sense. So, I don't want to. I mean, my opinion is obviously that Grok have misstepped here, right? It's not okay. But the other companies, I think they have a defense, which is that they are trying to stop it from happening.
Why can't it do maths? Well, let me rephrase that. No, let me not. AI, why can't it do maths? It seems to be able to do simple maths.
Yeah.
I tested it in one of my previous videos and gave it some longer digit numbers with decimal points after it, and it gave me different answers each time by quite a large amount.
I once gave it some encrypted text, and it just decrypted it for me by writing a sentence, right? And it didn't. There was no decryption, right? It's not. The answer is that it's a text language model, so it predicts the likely words. Now, if you ask it what 1 + 1 is, there are a lot of examples on the internet of people saying 1 + 1 = 2. It's in the training set, and so it will just write =2. It's not calculated the sum. In some sense, a bit like me, right? I now know that answer so well.
Yes.
The part of my brain that does complicated maths wasn't even turned on, right? It's just the normal gut reaction. But if you ask me to do a hard sum, I don't just say a number. I have to work it out.
And these models seem to be working it out in the same way when you open up the thinking that I would do. It's sort of talking about carrying the zero and knowing that it's going to be around this, the answer is going to be around this size. So it's doing some kind of very human working out, but it's getting the answer wrong.
No, it's not a perfect system. So you can't replace a calculator with this chain of thought, because the chain of thought derivation has the same hallucinations that normal text does. And so it will improve it, right? By asking it to do a long division, it's more likely to be able to do a long division than just to say the answer. But it's inherently a really stupid way to do it, right? Because we literally have calculators.
Yeah.
And they cost no electricity at all, essentially.
Well, we're talking about, one AI calling a different AI. If it recognizes a coding problem, then call the coding AI. I would have thought whenever it recognizes a maths problem, it just calls a calculator.
You would think, wouldn't you? Like, the fact that it doesn't boggles my mind. What they should be doing, they should be doing one of two things. It either writes a small Python program to do it and then executes the Python, or some other language, or it calls a calculator tool, right? Which some of them may now build in, right? The fact that they haven't is just the developers haven't got around to it, or haven't decided it was necessary, because most people aren't asking maths problems and things like this. This idea that we can get it to answer math problems by giving it enough training data is just a huge waste of energy, right? Yeah. It's just a complete waste of everyone's time, right? And they should stop doing that.
All right, final question. There are two here, but they both effectively ask the same thing. Habina and Maha, and I hope I pronounced both of those right, say, what if I ignore AI? How will that impact my life compared to my peers who actively embrace it and learn it? And then a variation on that question, what will I lose by not using AI?
Good questions. I think at the moment it's difficult to answer because we don't know what these companies that are throwing AI at everything are going to do, are going to find out. You know, one could imagine, but suppose we settle into a time where if you use Cursor to produce programming code and you audit the code and you write the tests and you do everything very carefully, let's say you're 20% faster. If you don't do that, you're then 20% slower than all your peers, right? So in some sense, that's a net loss. Now, you might be able to argue that your code is better quality, or you make fewer mistakes, or you can do more complex things, maybe, right? I don't know. And that will be a sort of case-by-case basis. I disagree with the companies that are saying you have to use AI because we want you to be more 20 just be 20% faster, because I think that, you know, the evidence is not there yet and we need to think about it. So if you don't use AI, you do run a risk that for jobs where it actually works, you set yourself at a disadvantage, right? A bit like there's those Nike shoes that have that carbon fiber heel and give you like a 5% running boost.
Oh, okay.
Right. And now all the marathon runners are wearing them, right? Because it doesn't matter how much you want or don't want that technology. I think there's like most of the vendors now do it, but it was it gives you like it's like a tiny bit of spring in your heel, right? It makes you slightly
if
faster.
I did any exercise at all, I probably know what you're talking about, but I don't.
I only know because it was in the news.
Right.
Now, as far as I know, those similar variants of those trainers are now worn, right? Similar to if there's a development in like swimming wear, they'll all be wearing it, right? There was that shark skin one where they all beat all the world records and they had to ban it, right? In a way, AI could be a little bit like that, where there are certain things where just do that thing and it's way faster, and then you'd just be wasting your own time not to do it. But I think it also depends on the job. If you're writing a book, right, you could make yourself maybe write more books and faster if you used AI, but your books might be lower quality, right? It's certainly not guaranteed they would be the same quality. So it's going to depend on what your job is, right? So I think if you don't use AI, the only risk you take is that there is some very obvious use cases that you miss out on. But to be honest, you could wait and just see what those use cases are before you jump in, right? And then just change your mind.
And then the nature of AI is that you can talk to them in natural language anyway. So it's not even that you had to learn something specific. I mean, you might, prompt engineering is a thing, isn't it? But you should be able to just start asking it in English for help on particular things.
Yeah. And it's not too late to learn, right? So you could just sit and wait for a while until the dust settles and everyone goes, okay, this is what they're actually useful for. This was stupid. This was good. And then do those things, right? And not worry about it.
Yeah.
The second question was, what are you missing out on if you don't use AI? I don't use AI that much because I prefer to read things myself that people have written, right? And I have a lot of meetings anyway where I'm talking to someone face to face and AI doesn't need to be involved. The main benefit I found in using AI is explaining to me something that would take me a little bit longer to understand if I was just doing it off my own back, right? I'm quite busy. I need to learn a lot of new things for my job all the time. So quickly explain it to me. And if I have further questions or I need to know more, I'll go and read the paper, right? And things like this. Those kind of quick wins, I think, are a good reason to use AI. But I only do it a little bit to sort of just give myself a little bit of a boost rather than to replace 2 hours of work, which I don't think is plausible.
I was going to give a couple of examples of how I use it. I do a lot of writing, and every so often I'm stuck for a word, or I know I want a bit of alliteration. And so I will ask AI to suggest some things, and sometimes I use those phrases and sometimes I don't. I don't get it to write anything even as long as a sentence because, that just doesn't feel right for me to do. We're recording this on Riverside, and like many of these platforms, once I hit stop, it will provide this video with a transcript, and it will auto-select what it says are the best bits.
Yeah.
What I've found is none of those are usable as they are. But I do I do use it to choose the best kind of chunks and split it up in. So you might get a 5-minute video about Spen and Mike talk about this section here. And then they talk about another section and it'll cut a different video for that. And so it's kind of doing that first, what I would call a low skilled job of chunking it up. but the actual edits it makes, I always have to unwind.
Yeah.
Because they're not good enough. But at the same time, you can talk to the video editor in natural language, surprise, surprise, and say, make me a 3-minute video, landscape formats of all the fun bits, at which point it makes possibly a portrait video because it hasn't understood that of some bits. But unfortunately for me, I still don't trust it to make good creative decisions for me. I don't know if that's a good thing or a bad thing, but there's hints of how it could save me time there.
And one of two things will happen right over the next 5 years. Either they'll sort those things out and then it will be more useful, or you'll still be using it as just a kind of a guide or a quick hint or a small helper. And it doesn't really matter which of those things comes true, right? It's still kind of useful either way. I think that as long as you're in the loop, you've got ownership of that thing. I think that it's sometimes also just fun to use AI, right? So we forget that we spent ages messing around with image generation, right? You've done loads of audio generation.
I tell you, I've released an album on Spotify, for goodness sake.
Right? We've got a computer file video where one of my PhD students creates a fake me to try and replace me on computer file with mixed results, and there's a strange video of me eating spaghetti and stuff. It can be now. We can ask whether anyone really needed to see those things, right? But actually, it can be fun, and part of being a human is experiencing new things, and this is new, right? So that's good. So it's not all bad, right? We can't be too grumpy about it.
Oh, that's a good note to finish on. Thank you so much for doing this extra bit of work here. And now you have to go and teach a whole cohort of degree students either to pass with AI, pass without AI, or use AI in a morally correct way.
Yeah, they're going to have to explain cryptography in an exam, so they want to come to the lectures if they're watching. Come to the lectures.
Thank you.
No problem. Lovely to be here.
This has been Spencer Kelly's AI Masterclass. Thank you so much for being there. I have a feeling this is not the last AI Masterclass we're going to do. What do you think? Yeah. So might see you at the next one. In the meantime, check out spencerkelly.com if you want to know more about what I'm up to. I do loads of talks at events about AI and everything else to do with technology too. I host panels and I train people on how to tell their technology stories either in front of the camera or on stage too. If you need any of that, spencerkelly.com is the place to go. Thanks for watching. I will see you soon.